All right, so we're recording this video so that it can help you to answer the first revision worksheet on the IGCSE course. All right, so I'm just going to show you the first worksheet on the revision resources section, and it starts with a recap of everything a student would have done in year 9 so that it prepares you for the IGCSE course. And it starts with fractions, and number 1 is just a simplification exercise whereby you've got 12 or 18. So this one is actually an easy one to do. So you just need to find a number by which you can divide both 12 and 18, and you try to find the highest common factor actually. So in this case we can divide both 12 and 18 by one number. You need to find it, and this number is actually 6 here, because you can divide 12 by 6, you get 2, you can divide 18 by 6, you get 3, so the final answer is 2/3. All right, if I look at the second one, it's asking you to give you a number, to convert a fraction to a mixed number. So I'm not going to answer the question on the worksheet itself, but I'm just going to take another one. So let's say you have to divide 5 by 3. If you divide 5 by 3, you can write it like that. And we're going to try to attempt to do long division here. 3 goes into 3 only once. Okay, and if you subtract, you get a remainder of 2. So 5 over 3 can actually be written as 1, which is the answer you get here, and then 2/3. All right, in the same way, if I have 7 over 4, same technique, 7 divided by 4, so 4 goes into 7 once, and you've used 4, you're left with 3. So this can be written as 1, the 1 is this one here, and then 3 over 4. Okay, so this is called a mixed number. After that, you've done long division, and if you're dividing by a factor of the number, I mean 7 over 7 is 1, no remainder. Let's say you're taking 8 over 4, you get exactly 2, then there is no remainder. So you can't express as a mixed number, right? So that's how you would attempt the second question, where they're asking you to find the fraction but in mixed form. Okay, so let's go back to the worksheet. So number 3 and 4 is about addition and subtraction of fractions. And usually if you need to add or subtract fractions, one thing you need to keep in mind is that you need to have the same LCM. So once again, I'm not going to answer the question on the worksheet, but just give you another one. So let's say I need to add 2/3 to 1/4. Okay, so the denominators are different here, and so we can't add the fractions. When is it possible to add? Let's say I have 1/3 plus 2/3. So here we have the same denominator. The outcome is just 1 plus 2, 3. 3 over 3, which is 1. So here it's not the same, it's different. So we actually have to find a way so that we get the same denominator. And usually what you do is you multiply this denominator by the other one, and you multiply the other denominator by this one. So I will take the 3 and multiply to the 4, and the 4 will be multiplied to the 3. Okay, and since you have multiplied by 4 here in the denominator, you need to do the same in the numerator. Since you have multiplied by 3 here, you need to do the same in the numerator. So you end up getting 8 over 12 plus 3 over 12, and then it's just 8 plus 3, 11 over 12. And the same technique can be used if it's subtraction as well. So let's go back. So the addition subtraction question can be done using whatever I've just showed you. Now what about multiplication of fractions? When you need to multiply fractions, you don't need to have the same denominator. All right? So when you're multiplying two fractions, what you do is you multiply the numerators, divide by, and you multiply the denominators. Now some people, before writing this step, they actually end up cancelling things, which is a good idea, but I just wanted to explain to you that we need to multiply the numerators and we need to multiply the denominators. And each product goes to its required place. Okay, when I'm multiplying numerators, it's up there. When I'm multiplying denominators, it's down here. And then from here, actually the 2 goes into 8 4 times. The 3 goes into 9 3 times. So I end up getting 1 times 4, 4, 1 times 3, 3. This is the final answer. So if you're multiplying fractions, make sure that you do cancel things out if you have to cancel. Otherwise, if you're just working with the numbers and trying to multiply, you may end up getting big numbers, which we don't want to have because we try to give in the simplest form. Now, number 6 is about division of fractions. Let's dive into this one. This one is quite an interesting one. So let's say you have 1/3 divided by 8/9. Okay? When you're dealing with division, what happens is that the division needs to become multiplication. And when the division becomes multiplication, you do the reciprocal of the fraction, of the second fraction. So 8/9 becomes 9/8. And once we have this format, we can do our thing. So 2 goes into 8 4 times, 3 goes into 9 3 times. So I end up getting 1 times 3, 3, 1 times 4, 4. So the final answer is 3/4. Okay, so with these skills I've just explained, you should be able to complete the first section of the worksheet. What about the second section now? So the second section is about indices. If you're multiplying and you have the same base, you add the powers. If you're dividing, you have the same base, you subtract the powers. So for number 1, 3 power 2 times 3 power 4, that would be 3 power 2 plus 4, which is 6. This is another rule whereby you have 2 powers and they can multiply to each other. So 4 cubed to the square, you just multiply the 3 to 2, it's 4 power 6. And square root means power half. So that's 81 to the power of half. Let me just show you how this one works out. So I'm not going to use 81, but I'm going to use another number. But before showing that to you, let me just erase this. So the square root means power half. Okay, and this is quite helpful in simplification and solving cases. So let's say you have root of 36. That means 36 to the power half. And 36 is 6 to the square. And these two cancel out and you get 6 as answer. And when you're doing root of 36 now, there's usually a plus and minus here. So it's plus or minus 6. Because when you're doing square root, you're actually trying to go back to which number you squared to get 36. So that could be minus 6 to the square, which gives you a 36, and it could be just 6 to the square, which gives you a 36. So you have 2 possibilities, and you need to take both possibilities into account when you try to solve. Let's go back. So that was for number 4. Number 5. So number 5 is a solving process where you actually need to bring that number to the same base. So let's say I have 5 power x equal to 125. So 125, I'll need to write it as a base of 5. So that would be 5 to the power of 3. Okay, and then since you have the same base, you can actually equate the powers. Okay, so that's one thing which is going to be helpful for the other question. And then I can see that there's a negative index here. So what do you do when you have a negative index? Once again, for the negative index you have another rule. So maybe it's a good idea that I summarize all the different rules you have for indices so that you can actually use them. So the first rule is that if you have the same base and you're multiplying, you add the powers, which was I think number 1. If you're dividing, you actually subtract the powers. And then if you have 2 powers like that, you can just multiply them. And then if you have a negative power, that's similar to 1 over the same thing but to a positive power. Meaning if you have 2 negative 3 to the power 2 to the power of negative 3, it's the same as 1 over 2 to the cube, which is 1 over 8. So that's quite helpful. Okay. Section 3. So section 3 would be simplification. So number 1 is adding of like terms. So they're all in terms of x, so you can just add them. So 5 plus 3 is 8. 8 minus 2, 6, 6. So it's just 6x. Here you're expanding. Number 3 is factorizing. So you take out what's common. So you have 6y minus 9. You would take out the 3. I can just quickly show you on the board. I'm going to use other numbers as I usually do. So 4x minus 8, if I have to factorize it, I need to find what's common between these two terms. So here it's 4, which is common. So 4 open bracket. What's left inside is x minus 2. How do I get them? And the 4x divided by 4 gives me x, minus stays the same. A divided by 4 gives me 2. So that's a quick way to do factorization, and that's what they expect you to do here. Number 4, you'll need to expand and then group the like terms and solve. Number 5 is just expanding. Maybe I can just quickly show you how we expand with 2 brackets. So let me just erase this. Okay, so let us look at the expansion of 2 brackets. So if you have x plus 2 times x plus 3, one way of doing it is actually doing 1 by 1. So x times x, x squared, x times 3, 3x, 2 times x, 2x, 2 times 3, 6. So you get x squared plus 5x plus 6. So you can use that technique to actually expand brackets. Okay, we go back again. So that will be useful here. You can use the same technique to expand here, then send all the x terms to the left and then try to solve for x. Number 6 is factorization of a quadratic equation. There's already a video on the web page for this one, factorization of algebraic functions, under the algebra section, so you can go and check it. This one is just expansion. And like I said, quadratic equations, we already have it under algebra, so you can go and check it. Perhaps before we close the video, maybe I can try to show you something which is a bit challenging perhaps. So let's say we look at section 3, number 7. So 3x squared plus 9x over 3x. And we need to simplify that. So 3x squared plus 9x over 3x, and we need to simplify. So I'm going to actually look at the numerator first. And then I can see that there is 3 common between the 2 terms, and there's x common. So I take it out. Then, like I explained to you before, I take 3x squared divided by 3x, I get x, which goes in. 9x divided by 3x, you're left with 3. Divided by 3x, and these 2 cancel out, and you're left with x plus 3. So that becomes the answer. Okay, let us just go back and check whether there is any other question which I could clarify with you. These ones are just normal expansions. Section 5, number 1. So that's a difference of squares, okay, which is different to the way you factorize normal quadratic equation. So let me wrap up the session with difference of squares actually, which is very important technique in IGCSE math, because most of the time you do get questions on difference of squares. So if I look at the general formula first, so it's called difference of squares because it is about difference of 2 numbers being squared. Look at the formula. It's a squared minus b squared. So you have 2 numbers being squared, and it's a difference between them. You have a minus between them. So if you have a squared minus b squared, it gets factorized into a plus b times a minus b. This is what the formula of difference of squares is. So what it means is that if you have x squared minus 3 to the square, the a is x, the b is 3, it just becomes x plus 3. x negative 3. And you can actually expand to check that to get the same outcome. I can quickly do it for you. X times x is x squared, x times minus 3x. 3 times x is plus 3x, 3 times negative 3, negative 9. This cancels out, you're left with x squared minus 9, which is actually x squared minus 3 squared. So we basically checked that is true. Now, how do we use it? Let's say we have x squared minus 25. We can see that there's a minus between the two terms, and the second term can be written as 5 to the square, so it is a difference of squares. And this will become x plus 5 times x minus 5. In the same way, you can have x squared minus 49, which will be x plus 7 times x minus 7, because 49 is 7 to the square. And sometimes they hide a difference of squares within an expression. So for example, you can have 4x squared minus 16. You need to realize that this can be written as 2x to the square minus 4 to the square, because 2x to the square gives you 4x squared. Then it becomes 2x plus 4 times 2x minus 4. Okay, so I think that I've given you a good overview of what's needed for the worksheet. Okay, over here, which is good revision for the end of year 9. We're going to do another video to focus on the angles and trig and total surface area part later, but this video should actually help you to cover the first few sections, okay, of the worksheet. So good luck with that one. All right, see ya.